right, let's talk about trilobites. So, trilobites are mostly known from the top part of their exoskeleton, which is like a shield and it's going to cover most of their body. When they fossilized, that part was well enough held together, like the parts that you can see on top here, that they would tend to fossilize, or you would at least get chunks where large sections of the body would be held together. What is very rarely preserved are the things underneath, and those are what makes a trilobite different from other arthropods, what makes a trilobite. So, shown here, this is Triarthus, and this is from a special place called Beecher's Trilobite Bed, which I believe is in New York State, and it's this tiny, thin little bed that was found and then lost for almost 100 years, and then they found something like it nearby finally. And the trilobites there are pyritized. They're basically turned to fool's gold, and they preserve a lot of the internal parts, or at least the delicate external parts. So you can actually see what a trilobite is. So it's got this big shell, and underneath the big shell is a rather skinny little, it kind of looks like an insect or a centipede, some sort of arthropod. What we've got are, here's some antenna up at the front, and you can see those were quite flexible, probably had some sort of sensory function. Up near the head end, you can see there's a lot of parts that may very well be mouth parts in there under the cephalon. And back here, each of the segments is going to have a pair of legs either side, and they're going to be jointed appendages, because these are arthropods. And then behind that, what you can't see very well in this fossil, there are going to be gills. So there's a little set of external gills, like little feathers, that sit on top of each of these walking legs. And we'll show you a little more about those in a minute. All right, so this is from one of the most exciting recent papers. This is a set of trilobite mummies, essentially. Now, they're preserved in Morocco. These are from fairly early in the Cambrian, which is trilobites don't appear at the bottom of the Cambrian. They take a while, and trilobites are, I believe, still the first sort of arthropods to appear in the Cambrian, like the first secure body fossils that we get. There are older things, but they're in deposits like those small shelly fauna, where they're all little bits of broken up animals of all sorts that have been sort of washed together. And those are more difficult to interpret, but may include some things like chancellorids, may include some things like primitive arthropods, possibly, but definitely lobopodians, like things like hallucigenia, the little guy with the sort of sticks on its back walking along on the bottom, little tiny thing. Anyway, these are preserved in a way that actually it's just the hollow in the rocks. They cracked the rock open. There was a hollow space, but they could see all the legs. And so from that, they're able to make a scan, and you can see we're missing the top of the rock where it was cracked off. But those scans show detailed pictures of exactly where the gills were. Preservation must have been so rapid on these things. And I selected this picture because look what's growing on the cephalon of the trilobite. There are a bunch of little tiny brachiopods that are growing on there. And now trilobites are ecdysozoan, so that means they're going to shed their shells in order to grow, and they're going to continue to do this throughout life as far as we're aware, like a lobster or something like that. So they'll get rid of the old and they'll keep growing. And so these brachiopods get a free ride for now, but time's going to come when they're left with their own little hard surface that they have colonized, and I think they'll be quite happy, honestly. I don't think they'll mind that at all. So, what else do we know about trilobites, which are fantastic? Well, here are some of the groups of trilobites, and you can see that they really start radiating out, not at the bottom of the Cambrian, but in what they call Series 2 of the Cambrian. So around the time, just a little before, you start to get things like Chengjiang biota appearing over in China. You get just rapid multiplication of trilobites. These are some of the earliest really successful arthropods, and they go on to great success through the Ordovician, Silurian. They get kind of hammered in the Devonian. There's a big set of extinctions around the middle of the Devonian. Several groups make it through. The end of the Devonian, though, they are not doing so well. There's only one lineage that limps its way to the end of the Permian, and then the great big bad end Permian extinction just takes them out. But it's not just trilobites. There are a bunch of related things. And so one way people classify these is you call them all trilobitomorphs. So things that are shaped like trilobites is basically what that translates to. And that's going to include soft-shelled forms like this. Now, we've got plenty of those early Cambrian trilobites from Chengjiang in the collection, and we've got several of these nectaspids, which are going to be like a soft-bodied, sort of like a trilobite. But trilobites are known for having 3 lobes. So if we watch this one up here come across again, after we get past the logo, there's going to be the head part that has the eyes on it. That's going to be called the cephalon, and that's where your mouth parts are going to come out. Then you're going to get the middle section, which has all those little segments, and that's going to be the thorax. And then the tail part is called a pygidium, which is also a name that's generally applied to kind of the tail piece on arthropods. And so the walking leg gill pairs are mostly going to be underneath the thorax section, although there are a couple of leg gill pairs all the way up in the cephalon. Most of the cephalon, if you were to pull this apart and look at just inside the organism, not just under the big hollow shell, you would find that most of that is digestive tissue up there, which is then passed down the length of the body, and there's an anus toward the end near the pygidium. All right, who's related to trilobites? These guys. This is Morella splendens. And looking at that on the top, you would say, I can tell the difference. That is not a trilobite. Yeah, I am not fooled. And that's good. Yeah, you got good eyes. Yeah. But these are very trilobite-like. And so these are a very common fossil in the Burgess Shale up in Canada. And it's like if you had a trilobite body. So this is like roughly the same sort of thing as the trilobite body down here. But instead of having that big sort of dome shell that goes over the entire thing and covers up its scrawny, skinny, it's like a dog when you get it wet that just shrinks down to nothing, or a cat, after it's had a bath. This one replaces the shell with these sort of pronged, it's like a headdress, but really it's just a cephalon. Nice little hard parts that are going to cover it over. These may have served a don't eat me function, especially if it were to sort of curl up a little bit, which would put those in the air. These are thought to be little things that would either swim around a bit or crawl along the benthos, the sea bottom, and filter feed down there. Not filter feed, but sort of scavenge. They will have pairs of walking legs, and right behind the walking legs there are little gills, just like in a trilobite. So that's what makes them trilobitomorphs, is the little gills on top of the legs. Here's another one from one of these awesome Silurian papers where they go in and serial section the thing and grind it until it's gone and then reconstruct it in 3 dimensions, like fossil magic. This is a Xylochorus, and this one has a big, like, one-piece shield. So it's not a trilobite because it doesn't have the 3 lobes, but we're just talking about the external armor. If we're talking about the stuff that's underneath, it's very trilobite-like. Here's all your sort of walking or maybe swimming legs with a gill pair sitting on top of each of those. The front legs are highly modified. These things are huge in Xylochorus, and there you go. Yeah. Here's a Vaconesia, and this is another little morellomorph critter, and this also has those great big sort of enlarged front appendages and just the smaller reduced walking leg and gill pairs that you can see here. This one is going to be from the Hunsrück Shale, where everything is pyritized from over in Germany. All right. That's the end of Trilobites Part 1. Stick around for Trilobites Part 2. You'll like it.